So if you're looking for practical C++17, you're in the right room. Hopefully that's why you're here today. I wanted to preface this by saying I am covering the C++17 features that I found a use for in the work that I was doing. So if you're expecting like a complete overview of C++17 features, that is not this talk. That was Bryce. He did 2 full hours on it yesterday. You can watch that on YouTube. Hopefully my clicker works. So this is me. If you don't know who I am co-host of CppCast, host of C++ Weekly, which is my YouTube channel. Just crossed 10,000 subscribers. I'm very happy about that. And co-creator of CppCon. I'll talk about CppCon in a minute. And I'm a Microsoft MVP, which I always forget to mention for some reason. So I had to put it on a slide so I didn't forget it. So I am an independent contractor, and I am available for contracting and training. Those are some URLs you can look at. The next training I am doing is on Saturday here. It is not too late to sign up if you happen to be local to Seattle. If your flight already has you going back to Europe on Friday night, though, then you probably can't make it. So CppScript is an embedded scripting language that was co-designed by me specifically for embedding in C++. Supports Visual Studio, Clang, and GCC. Runs on Windows, Linux, Mac OS, and I have ported it and improved it for FreeBSD and Haiku, which is a little esoteric, but I wanted to prove that it had the portability that I wanted it to have. Currently requires C++14, which is part of what this talk is about. This is my experience porting it to C++17. And it is header only with no external dependencies, except you have to have the dynamic loader for your operating system. So if you're compiling, you might have to do -LDL. That's an operating system thing, not my problem. And designed for integration with C++. And this is going to come up a little bit too. All of the types that are shared between CppScript and C++ are the exact types. So if you share a double to CppScript, it's going to be a double from C++ and CppScript, exactly the same. This will come up in a minute. So again, this is my proving ground for these talks. I've actually got 3 talks. This is the first one, or the third one, depending on which order you look at it. Anyhow, that is about proving different concepts of C++ using CppScript as my base. It's about 25,000 lines of code, and I want to point that out. It is not a trivially sized project, but it is also not a gigantic project. I believe it is big enough to prove what I want to prove about various techniques in C++. And as you can see here, it's had lots of growing pains. We started with C++ 03 and using Boost with Boost shared pointer, which has, since there was no unique pointer in Boost, has led to its own level of pain of trying to backtrack from having some of the shared pointer stuff. On to C++ 11, 14, and 17. The cops are driving past, coming for one of you. And I've got lots of complex template usage for automatically deducing function types. So this is a real full example of using CppScript. You include a header file, expose a function. I've got the function on line 2 called greet. It is automatically has its types deduced, and then the result of this would be printing hello world from CppScript. So just so you know. OK, yes. So you're all settled down. But my talks are much better if I can interact with you, so feel free to stand up and move closer if you want to. I get one taker. Yes. You need to interrupt me and ask questions. That is how these work. Otherwise, I'll get bored and you'll get bored. Excuse me? So, interrupt, if you raise your hand and I don't see you, yell something out. Ideally, we use the microphones so that they get recorded, but I'll repeat the question also because I want to keep the conversation moving if at all possible. Hello? Oh, OK, sorry. So I wanted to mention Slack real quick since I am heavily involved in the C++ community. So if you are not on Slack, you can get on Slack and you can join in the conversation here, and maybe we'll flip back and forth a couple of times and see what people are saying about my talk during it. But this is the live Slack channel for CppCon that's going on right now. Okay. So I'm going to do an overview of the C++17 features that I used, and we will see where this gets us. So starting with structured bindings, again, this is going to be really high level. We're talking like one slide per feature. This is basically what a structured binding looks like. You have some expression. You can automatically decompose it into the components of the thing that was returned, obviously added in C++17. Has everyone been exposed to structured bindings yet? Mostly no. Some people, yes. So, well, that's the gist of it. It works just like auto deduction. You must use auto. It must be a comma-separated list of things inside of brackets. And, well, I mean, it can be auto, const auto ref. I think volatile can be used with it, but I'm not sure if I've actually tried that. Does anyone know if volatile can be used with structured bindings? No, it can't, says Bjarne. So, if init expressions, they allow us to do things like this. We can have an expression at the beginning of our if statement that we are using here with a structured binding. So this lets us set up something that's going to live just for the scope of our if statement. And this is interesting for limiting the scope of variables. And it also works for switch conditions, but I haven't actually put that to use yet in my own code. So the standard library also has a handful of changes. This is one of my favorites, even though it is like the tiniest thing in the world. Emplace back in sequence containers was changed to return a reference to the thing that was just added. So it's exactly like the slide shows there in the second block. Emplace back is returning a reference. I can have an auto ref, whatever it is, and capture reference to the thing returned. So instead of having, like, if you have a reason to add something to the back of a container and then immediately access it, this is neat. And it's tiny, but it's neat. String view. We've had some discussion about string view, I think, at the conference so far. Is everyone familiar with string view? It's supposed to be a lightweight wrapper around string-like things that is supposed to be the new language with which we talk about strings. So yeah, that's string view. They're automatically convertible to, from, string, and const char star. Nested namespaces. C++17, we can now do this. I love this. So if you have a reason to have multiple namespaces, you don't have to have an opening, open, 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 whatever. We'll get to what effect that had. Yes? You can have an anonymous namespace that's nested. How would you do an unnamed nested? Oh, can you? Oh yeah, no, I don't think you can. I can't think of any way that syntax could work. What? Oh, I'm sorry. Yes, was asking if it's possible to do an anonymous nested namespace like this. I don't believe so, because I don't think there's any way to give a name to a thing that you can't name, or not name a thing that you wanted to name, or however that would have to work out. So class template type deduction. Sorry. This is the gist of it now in C++17. If we want to use a class template, we don't necessarily have to specify the template parameters. So in C++11 and 14 land, we would need to say that this is a pair of int and double. In C++17 land, this gets automatically deduced for us based on the types that are passed to the constructor that was chosen. So in this case, it's able to see that we're taking our first and second by copy in our pairs constructor, and it's able to deduce that we want an int and a double pair. I'm sorry, what was that? Does it apply also for return types? This is, So the question is, would it also apply to, you're saying return type from a function, if you could automatically do that. That wouldn't, the only way for that to work would be for the function to actually return an auto, right? Because otherwise you have to specify what the function is returning. And if the function's returning an auto and you were to try to do this braced initial and initialized deduction, it's not going to know what you mean. So I think the answer is no for what you're asking. Is the explicit constructor required? I'm not sure I understand the question.
Because braced initialization.
Yes. That's an interesting question. I have not played with whether or not it would work in uniform initialization, braced initialization, you're saying, without a constructor at all. I'm not sure. It does, yes. It does work for aggregate construction, yes. OK. So then also deduction guides are added. So they look kind of like this. And again, it's supposed to be pretty high level thing. We're just saying if we're using forwarding references in our constructor, then we can tell the compiler what we mean by that. So for a more practical example, we have updated our pair so that it takes its 2 parameters by forwarding reference. And then we have our deduction guide on lines 12 and 13 that tells the compiler to decay those types so that it knows what we actually mean. I don't want to spend a ton of time on this. This is, well, this could be an entire hour. And it's, I think, been probably proven by at least some people that deduction guides are Turing complete. If const expr looks like this. We have compile time conditionals. So the things in the if and else must be syntactically correct. But you could be invoking methods that don't actually exist on some type if the thing doesn't match the thing. So if the first block, if the block is true, then the first thing is compiled. If the second block is true, then the second, or excuse me, if it's not true, then the else is compiled. And so this can have interesting impact on things like actually returning 2 different types from your function depending on the things that were passed in and using auto return type deduction in C++ 14 and 17 combined. Fold expressions. This is what fold expressions look like. These are for variadic parameter packs. So we've got unary left fold, unary right fold, binary left fold, binary right fold. I always find which one is left and right personally kind of confusing because I expect the dot to be, I expect the thing that I'm naming to be on the left, but really it's the dots that are on the left. But anyhow, it's allowed on these operations, which is basically almost every operator, except for, well, dot, but we don't have an overloaded dot operator yet anyhow. That'd be neat. Sorry. So this is the unary left fold. Basically, it's doing a leftwise grouping of the things that you are folding. And a unary right is doing a right-sided grouping of the things that are being folded. And then our binary left and binary right gives us an initialized, an init that we can put up there, and putting this true in here is absolutely completely meaningless because true and false is false. But this is for the sake of this example slide. And same for the binary right fold, we've got our init. So no except is now also part of the type system. And I think this is perhaps one of the more esoteric parts of C++ 17 that maybe most people aren't yet aware of because they haven't compiled their code on C++ 17 compilers yet, but we'll see. So this is what it means to me. So I've got a function that is expecting a pointer to a no except function. That's on line 1 on the top block. And then I am passing my func to it, which is not declared no except. In C++ 14, this can compile because it isn't making a determination as to whether or not the function pointer is no except. Is everyone at least okay with this? Do you have any questions? So in C++17, you have to add an extra overload if you're doing things with function pointers here and you want to do it in a generic way, things that can take no except or not no except function pointers. Does it work the other way around? Okay, so the question was, does it work the other way around? And if I did not, so on line 1, if that was not marked no except, and I wanted to pass in a no except function to it, yes, that would work still in C++17 also because it is it's a lower requirement. No except function pointer can be converted to a not no except function pointer. I really have a really hard time with the vocabulary there. With the not no except, I end up cascading all of these negatives. But yes, it would still work in C++17 also. Okay, now we're going to talk about the actual impact and how we define our impact. Well, I meant to ask you how you would define it, but then I accidentally went all the way forward here. So I'm looking at things like compile time, runtime, code size, and readability. And does anyone else have any other opinions as to what they would be looking to keep in mind for impact on their code? Maintainability, yes, I totally agree. Okay, yeah, maintainability. Code readability, oh, that's up there. I find maintainability and readability interesting ones, and we'll get into that when we actually start talking about the impact. Like, what is different, between, is something that's more readable necessarily more maintainable, or something that's maintainable more readable necessarily? Was that? No, okay. So, okay, I have a poll up if you have your internet-enabled device. strawpoll.com/W767K3KK. If you can see that, then you can vote as to what you think of these options. Class template, type deduction, if and init expressions, fold expressions, if const expr, structured bindings, string view, and placeback, nested namespace, and no except would have impact on an existing code base. And then I am going to go through them in order of least impact to most impact, and we'll Oh, no, I'm hearing that it does voting by IP address. Yeah, I can change that actually. Oh, I can't change it without modifying it now. Oh, well. We will see. We've got some votes. There's 3 IP addresses in the, all right, well, that is, yeah, I can't get off the Wi-Fi and still be able to look at this. So, well, some people are maybe not using the Wi-Fi. We'll see if we get any more. Anyone else hey, okay, we're actually getting some stuff here. All right, you can continue to vote. And we will move forward so you'll get progressively more disappointed or something as we reveal what the answers were. I will leave that up if someone is still trying to go to it. Should we check in and see what Slack is saying about the talk? Hey, I didn't even realize Jens was here. Okay, so answers from least to greatest. No except in the type system. This actually ended up causing a 2-time duplication of my function type deduction code in CppCon, which is not unexpected. But I have to have an overload for all of my function type deductions for things that can be no except. And the reason I discounted it a little bit here is it required some conditional compilation because I have to use a compiler feature macro to know if I'm compiling on a compiler that supports no except, to know if I should add the overloads, because otherwise I get ambiguous overloads on a C++14 compiler. But if you'll notice the last bullet, once I added these overloads, simply enabling the C++17 flag gives me a 1% performance improvement. And I believe it is because the compiler is able to do some better optimization of the code when it knows that the function it's going to invoke can't throw exceptions. So I give this, I actually ranked each one of these things, and then I give a final score at the bottom. What the actual values are, I guess, is hidden to me. But I got a minor performance improvement, and I considered a maintainability negative because you have to now deal with the fact that these are extra overloads. No compile time change, and no real readability to the code change, in my opinion, because it was already a whole mess of overloads anyhow. Next up, if-init expressions. Now, considering that it's very low on this list, you can already tell that it's not the top thing. This is terribly disappointing to me because I love limiting the scope of my variables and making everything as constant as possible and all that, so I was really hoping for something that would be a lot of fun here. But this is the basic gist. We get to move the initialization of the thing that we're switching on into the block. Yes, that is, I think, non-obvious to most people. It does that. The vel in the second block would carry it as visible in the else also, yes. It is as if you created a new scope that contains your entire if block and put this thing at the beginning of that new scope, and then you have your if block. So my code is fairly well modularized with fairly small functions most of the time. So I found that I had changes like this. And I find myself not as impressed as I would like to be. And then I kept finding myself going, well, how do I format this? I feel like I want to do the top block slightly more compact, but my brain is not yet used to reading code that looks like this, so I scan it and I don't realize that I'm doing an initialization at the front of that. And then the second block just ends up looking messy. I'm sorry, what was that? Why did I expect to be impressed? Because I just have this thing with making my variable scopes as absolutely as small as possible. It's just what I want to do, so I was hoping this is a new tool that would really impress me, and I guess I just wasn't as impressed as I wanted to be, perhaps. My expectations were too high. Does anyone have any opinions as to which one of these they think is more readable, by the way, so I can set my coding standards or anything? First one. Oh, wait, let's do this differently. Who says the first block is more readable? Well, that's basically everyone. All right.
I guess just do the same as you do for for loops.
Do the same that you do for for loops. That's a good way to put it, I think. Yeah, that works. So no performance impact, although it could potentially have performance impact if you are actually able to reduce the scope of variables that then the compiler can better reason about and could better optimize the lifetime of. Small maintainability thing, I think readability, it possibly hurt it for the reasons I already pointed out. Yeah. Yes? I do have locks in my code, but they tend to be, I've intentionally very limited where I have to have my locks. Yes, and locks, yes, and that's actually, locks is one of the cases that I like to also demo when I'm talking about this feature. Like, look, it could clean up your locks, but I didn't actually find a use for that in my code. Yes? Okay. Right, if you needed, in cases where you have empty braces for a lock or something like that, this could definitely be helpful. I think I had one other case, but oh, I like it because also if you're using regular expressions and you need to pass in the regex match object, then you could declare it there and then do the thing, and you could get the results back from the thing all in one thing. But I'm not using regex because it's not appropriate to my code. Nested namespaces are next. Oops. Oh no. Preview. So I have a fair number of nested namespaces because CppCon, as I mentioned, is a header-only library. So I use namespaces to kind of obfuscate some things. So I do things like this. And I found this like really, I was so surprised how satisfying it was to collapse my namespaces. Like, yes. And I know a lot of coding standards and organizations don't indent for each level of namespace, simply because it has too many indentations. I am not that person. I do indent for each level of namespace, so it just, I'm happy to be able to collapse them. However, when I was actually doing this in my code base, I noticed lots of large white space diffs when I would go to make my git commits, which is then made me sad. And then again, flipping back here, and the second block, if for some reason I had a need to add something to the CppCon namespace here, now what do? Do I change everything again? Do I add a CppCon namespace above this one that is just for the sake of having a CppCon namespace? I don't know. I haven't gotten there yet. Yes? Yes, it wouldn't be a problem if you don't indent namespaces. Like I said, I know that most people don't. I like indented namespaces. It's whatever. So just as, something to be aware, I felt like, no performance difference, maintainability, possibly negative. If you're like me, yes. I'm sorry, I can barely hear you. Don't mix the two styles. I thought about that, and that's why this line says, might make us rethink some of our coding and formatting standards. Because I was thinking, I could just have this CppCon dispatch detail, and then like the stuff that doesn't need to be in all three of them right below it, just have CppCon dispatch or whatever. Yeah, I think we'll be rethinking some of these things as we start to use them. Yes, I was correct to go there. Class template type deduction is up next. So C++17 adds a complete complement of deduction guides for the standard library types. So I'm going to now, we're approximately halfway through the features or something. We're 3 or 4 in. What impact, okay, so who thinks that class template type deduction with the standard library types had a good impact on my code? That's a question. Oh, then it's a question. You're not raising your hand to answer. Okay, so like being able to automatically deduce a vector of ints by passing in an init list of ints, for example. Well, okay, we'll get there. Maybe let's just, all right. And I just got my time card here saying I'm slightly running slower than I wanted to be. So I will say basically 0. And I will say why. At the class level or struct level where I'm declaring something that's a templated type, I can't use class template type deduction here. There's nothing to deduce on. So I must specify that it is a specific thing like a vector event. And let's just do, okay, so who here would argue that 1 is better, that A is better? And who would argue that B is better? And I get some half-hearted hands raised on both sides. So B, in this example, is having to instantiate a standard function In this particular case, it's probably not going to do any dynamic allocation because it would fall into the small function optimization, but there's no guarantee of that. B is like probably calculably significantly longer to compile because of all the templates that have to be instantiated. A is not. So in my particular code, I found myself that auto is way more important than class template deduction. So looking at this example, and this is leading to what you were saying about using initializer list, who thinks that these are good uses of class template type deduction? So I don't have to specify that this is a vector of unique pointers or a vector of strings. Let's raise your hand if you think this is a good idea. Wow. Almost no one. A handful? OK. OK, why do we think it's not a good idea? Yes, go ahead.
I was thinking about getting a demo that took a vector that took 2 iterators.
Yes.
And I was intending for it to be taking the iterator pair to construct a vector.
Right.
Constructed a vector of.
You're correct. You accidentally constructed a vector of iterators. But that would not happen in this particular case. OK, I will put this a different way. Can both of these samples compile? No, some nods. Anyone want to say why they can't compile, or at least why one of them can't compile? I have to wait now. I need someone to give an answer on this. Yeah, go ahead. Either.
An iterated list is containing const objects, so you can move from them.
You can't move from them. Yes, an initializer list is something that cannot be moved from. So the second set cannot compile because it is requiring us to make a copy of a unique pointer, which is impossible. And the first thing is just really not good performance because we have to create 2 copies of each of those strings, one that lives in the initializer list and one that is actually pushed into the resulting vector. And this is where I give the shameless self-promotion plug. If you want to know more about this, hire me to train your organization. This is one of the things that I love to talk about. All right. So I would say class template type deduction is possibly negative if you're not thinking about what you're asking the compiler to do. Maybe some maintainability improvements, maybe some readability improvements. Does the problem go away if you don't use brace to knit? That's a fascinating question. If I didn't use brace to knit, how would I take advantage of the class template type deduction?
Well, I don't know what the vector probably has 5,000 instructions, but it might have a variadic pack expansion.
It does not. So vector does not have a variadic pack expansion that I am aware of. An initializer list is the prescribed way to do that. And you might convince it to grab one of the other overloads that's like, I want to create like 10 integers kind of thing. But I'm not sure. I don't think so. I think this is always, yes?
I think it's more useful when you have types that are related, like pair is related to map,
Yes.
blocks are related to mutex. But for containers, it's actually a full type, so it's less interesting.
Yeah, the comment was that for containers, it's less interesting, but for things like pair or tuples, perhaps, things that are also related to the pair that lives inside a map, better. Move faster. Yes. Go ahead, real quick. Okay. No. Yeah, no, it would not be able to deduce that. If it was a bunch of, you're saying related types that were passed in, no. You would have the same problem that you have in the initializer list. It wouldn't compile. So, all right. So next up, structured bindings. And I like this, and I am going to try to move a little bit faster, like I said. So I like this because it helps clean up our code. If we're doing something like this, this is real code from CppCon. I have a function that helps me dump all the types that are currently registered in the system. If you have the first thing with the ranged for loop, that's already way better than what we had in C++ pre-11. But then with C++17, we can do the structured binding, and we can reason about the things that we're actually like accessing. Instead of having first and second, this is good. Is there any performance impact? And let's do this quick. Who thinks the first one is better? The first one, I'm getting like more and more people raising their hands. OK, who thinks the second one is better? I'm only getting like 3 hands. The why is that we are forcing a move instead of letting the compiler do a return value optimization here. So we don't want to return by move. That's, yes. So who thinks the first one in this example is better? I am not taking questions at this time. No. OK, so a couple of you think the first one's better. Who keeps the second one is better? We have a lot of undecided people in the room. The first one is, I've highlighted them opposite in this answer, sorry. The first one is worst because our return value optimization cannot apply to the sub-object. So if we actually need to return efficiently a sub-object from our pair, we need to return by move in this particular case. So who thinks the first one is better here now that we're using structured bindings? Well, so almost, OK, lots of people think the first one is better. All right, who thinks the second one's better? OK. We still have exactly the same problem. Return value optimization cannot apply to a sub-object. That value is still a sub-object of the thing that was returned from the function. In this case, move is better because it is not what you're expecting. Yes?
And the compiler is not allowed to just make, and generate the code like if succeeded, it didn't exist.
I don't believe the compiler is allowed to do it in an efficient way, and I have not seen a compiler that does. And it is because in the standard, bindings are specified as if you had done this, as if you had created some mythical object called E, that is the thing that was returned from the function, and then you create references into the thing that was returned from the function. Yes?
Do you consider this logical, or is it a flaw in the language?
I am not qualified to say if this is a flaw in the language or not. I honestly don't know how it could be done better. So I don't know if there's a different answer. Yes? What if E has a non-trivial destructor? Then it's this, the lifetime of the things that were the binding is the lifetime of the thing that was returned. It works exactly like you would expect it to, just not in the way you would expect it to. So potentially very negative performance impact here, because now you have to consider the source of your variable. And in my opinion, in no other part of the C++ language do we have to think about where did this variable come from when we're determining how we need to work with it and how we need to return it. Minor maintainability help. Potentially huge readability help. So it gets points. And like I said in my scoring system that I didn't reveal to you, it now has a score of 2. Fold expressions are next. Basically, they are where they are in my list because virtually everything that you can do with a C++17 fold expression can be done with a C++11 initializer list hack. It is not pretty, but I have done a few episodes of this on C++ Weekly. You can check them out so that I don't get into it too much in detail here. But oh, what in the world? Got a lag in my clicker. So Let's look at this real quick and make sure, does everyone agree that both of these versions have a well-defined order of evaluation? Does the fold expression do the void trick? No, it does not. It is applying the comma operator, which, spoiler alert, is why both of these have well-defined order of evaluation, because they are relying on the comma operator being, well, by the old terminology, a sequence point, so that we know that they're going to be evaluated left to right in order, which is definitely distinct from making a function call. So yeah, so this code, and this is like stripped right out of CppCon. I am actually doing this exact thing right here. I'm calling trace on a bunch of things that were in a parameter pack for one of my templates. So so this is what the resulting code looks like. I am using the comma operator expansion fold expression, and I have to put it in parentheses to tell the compiler I'm doing a fold expression. And I find this, like I look at it, and even though I'm the one that wrote it, I find myself going a little bit like, wait, why is there a parenthesized thing in the middle of this function block? But this is doing exactly what I need it to do, and it is correct. So I said performance, no impact, minor maintainability thing. I ultimately concluded there was no negatives here, but I think potentially it could impact your readability negatively, depending on, it's one of those things we have to get used to. So now in place back is the next thing. It is getting higher on our list here. And we have this code where I am adding an object into CppCon and then getting the, it's exactly what in place back was designed for. You can see on lines 14 and 15, adding the thing and then I'm getting it back out. I simply made it this, and that was good. I actually measured a tiny performance improvement on this, teeny tiny performance improvement, because it was one less function call that I had to actually do. And I think it helps maintainability and readability a tiny bit, makes the code more understandable. What's my time? OK. All right, string view is up next. So the main impact for me on using string view was looking up identifiers and avoiding temporary strings, but it comes with a complexity cost that I don't think we're all expecting. So just to be clear, what does this constructor for string view need to do to actually make a string view object? It has to call string length, yes. Now, there is a very good chance it is done at compile time, if the compiler has direct access to the const_car literal that you passed into it, but it might not be. So now we have this world where we already had const_car star could be automatically implicitly converted to a string, which has been the source of headaches for performance in my code. Now we have an expanding world. Strings can be automatically converted to string views, const_car star can be automatically converted to string, and const_car star can be automatically converted to string view. So we've got this intersecting thing. And the operator less than, or all the comparison operators exist for string and string view like this. So if you want to do a string view less than a standard string, that's going to compile and work because it's going to implicitly convert your string into a string view and then call the less than operator for comparing string views together. So is this code good? Let's say yes or no if this code is good. I'm getting lots of nods, some shrugged shoulders. No, no, no. I think I'm going to make someone cry over here. This code compiles without warning on any compiler, just so you know. It is creating probably a pointer to a temporary that was passed in, because the string is going to be implicitly converted into a string view, and the string view is a pointer to the data that's inside the string, and then that is being pushed into our map. Yay, dangling pointers with no warnings. So storing a map of string view is extremely risky, and like I said, no compiler warnings. So we flip it around. Now we're using string view as our language for talking about strings. We have a map of strings to ints, and we want to pass a string view into it. Does this compile? Yeah, raise your hand if it does compile. Okay, no, it doesn't compile. Because there's no conversion from string view to string implicitly, and the at method requires a string, not a string view. So the answer to this is to use isTransparent comparators added in C++ 14. And we can do that like this. On line 1, we are using the stood less template that takes the void types. And that is giving us a isTransparent comparator. I don't have time to go into the details of what that means exactly, but it allows the library, when we call find on the map, specifically I believe find is the only method that works with transparent comparators, it's able to automatically look up our string here, and now we compile. So the question is, now what are we doing when this find is called? Because we're using this less than comparison. Real quick, anyone? So every comparison, I'm just going to move forward, sorry. For every comparison that happens, we are having to implicitly convert the stored string in our map into a string view so that it can be less than compared. So this is going somewhere. How do we do better? This is what the standard library version looks like. So it takes any two left-hand, right-hand sides and simply returns less than on it, and then declares the isTransparent so that the standard library implementation of map in the find method can know that it can do this thing. This is what my version looks like that I've added in CppCon. Excuse me? Oh, sorry, thought I heard someone say, oh, it's a weird echo right there. There we go. So this is what my version looks like. I have a string-to-string comparison that returns the less than as we would expect it to, and I have one that does lexicographical compare, standard algorithm, to return the less than between the iterator pairs of the things that are stored in there. This is highly dependent, I am quite sure, on compiler and optimizer settings, but in GCC 7.2, adding my version of this less than comparator was a 2% savings in CppCon. And keep in mind that this is across all of my performance tests, but this only affects the parsing of CppCon. This doesn't happen at runtime once a script has already been parsed. So this is significant to me. Also, don't do this. This compiles without warning. It's happy. There's automatic conversions here. So we pass in a string view into our constructor, and then we are converting that into a string. And this is perfectly valid. However, it kind of decays into this by the time you talk about factory methods or factory functions. So we've got this make s that we're passing a string in and moving that into the thing that's expecting the string view, and then using that to create a string from the thing. So we've gone, well, it becomes this, where we pass in a const_char literal, which is implicitly converted to a string, which is moved into a string view, which is moved into a string. Yeah, and as I say here, not actually contrived. I was like 85% of the way of done converting CppCon to using string view internally for the parser, and said, oh no, what have I done? Yes, so if you know that you're ultimately going to create a string, make the whole call chain take strings. So I gave this possibly huge, either good or bad on performance if you're not paying attention. Minor thing I did not mention here, the remove prefix and remove suffix methods on string view are amazing. If you're doing parsing things and you can just kind of narrow in on the thing that you want, that's really great, way cheaper than doing it with strings. I got a minor compile time improvement And I like the readability aspect of knowing that you're working with a string view, not with a string or something that you expect to be able to mutate. So this is basically everything that we just talked about, although I would like to point out that GCC 7.2 still has a bug with creating a string view and a context per context, but that has been fixed on trunk. All right, next up, if context per. Whoops, keep doing that. So I have a fair bit of code in CppCon that has to do some enable if kind of things. And so this is real world exactly pulled from it, and this is returning values from functions. And well, this is actually returning member variables that have been exposed to CppCon. So I have to determine if I've got, let's see, what are the two versions here? If it's a pointer that was passed, or if it's a pointer that's being returned versus not a pointer that's being returned. And I have two different ways that I have to handle it, and anyhow. So I was able to merge them into one version. I like if context per, it made me happy, and it helped a lot for some code that's like this, where I have to make determinations based on type. It eliminated about half of my Sphinx usage. Can anyone guess why it didn't eliminate all of my Sphinx usage? Anyone? Oh, no, wait, I have someone raising their hand so far away I can barely see there's a person over there. Yes? Yes, to actively deactivate function calls that should not be called. And that is basically, yes, constructors and other things where you might have a mix of templated and other overloads. So I have this, which is my version of ini. It's slightly different from C++ 17's ini, and that's partially because, well, I didn't have C++ 17 when I wrote it. And I have my constructor, which I have dutifully disabled. It takes a forwarding reference, but I have disabled it for taking the type, and we just heard about that this morning, why this is important. So it disables itself if you pass in an ini, and this is so that the proper copy constructor or move constructor can be called. So if we were to unfold this, and I think I got all this code right, then we can make it say, well, we've just got this forwarding reference that we want to take, and then we're going to create our helper function called makeData. And inside makeData, we're going to do our if context per thing. And we're going to say, well, if it's an ini, then we're going to copy it. Otherwise, we will actually create the thing from the thing that was passed in, which has a problem. Does anyone see it? We don't allow moves. So we can continue to expand this and have another level of if context per and say, well, if the thing that was passed in was in fact an ini, but a non-const R value reference, then we can say that we want to move the data. Otherwise, we'll copy the data. Otherwise, it'll be an all pointer. Well, I don't like Sphinx. To me, it's my least favorite part of C++, but I'm sticking with just using it for this particular case. So on a side note of this is I've got a type inside of CppCon called boxed number, which allows you to do any operation on any other type of thing. So whatever arithmetic operation you want to perform, it maintains the proper types. And this results in a huge explosion of multiplication of arithmetic types that are generated at compile time for me. If context per allowed me to rewrite this code massively, removing 160 lines of code in there, and I was really happy. I think I got a minor performance improvement and a more linear flow of my code. So, well, I say no here. Minor performance gains, large maintainability gains. I did help with my compile time a little bit, and readability help. And now we're all the way up to a 5. If we recall, we started at what, -0.5, I think. So class template deduction guides, I'm going to mention separately from class template deduction, because I didn't actually use the types that were created from class template deduction. I didn't use the instantiated classes. I just let them do the dirty work for me. So in CppCon, I did have many overloads that looked like this, where I took a function that, let's see, the first one is a function pointer, the second one is a member pointer that is const. And that's 2 of the very many that I had, because I needed to have these for const, non-const, no except, not no except, and member functions versus free functions versus member variables. Instead, I was able to break this down into a set of class template deduction guides, which I then used to tell me what I needed to actually do. And again, covering the scope of what I actually did here is, well, we've only got like 3 minutes left, so definitely not going to happen right now. But I didn't have slides for it anyhow, so you're not missing out. And so I have all of these template deduction guides plus one simple function that does the dirty work. So I ended up with a no change in lines of code. However, I was able to add R-value reference and reference specifiers and volatile specifiers. So I ended up with 8 times the coverage. I now can support every possible method signature in CppCon and had a 0 net on my lines of code. And that made me, I liked that. So now I'm up to a score of 6. Possibly some minor performance gains. My code is significantly simpler. I think it resulted in smaller binaries. Large maintainability gains, some compile time help, and large readability gains for my case. And so there are many const expr things that we didn't talk about that are in the standard library, like const expr Lambda support. That's not in the standard library. That's a core language feature. But that's handy. And I kept finding that it was actually the little things that I felt like had the biggest impact. So we're able to do maybe unused instead of casting a variable to void to get the compiler to stop complaining at us if it's something like a variadic expansion and we don't know if a variable is going to be used. Being able to do decay t instead of type name standard decay : type. This was added in C++17, decay t and the underscore t and the underscore v helpers. And yeah, that made my code way more readable and my heavily templated stuff. And so again, this is me, and those are those URLs that I had up. And there are CppCast stickers up here if you want any swag. But I think I have concluded on time. Is there any questions? Anyone? Hey, it saves time if I answer all your questions during the middle of the talk. I'll start over here first.
Did you try some new library stuff?
Did I try some new library stuff? Only, well, I have an entire other talk about optional, and that didn't come up in here. I just the in-place back and const expr array. Those are the main things from the standard library that really impacted my code. And I think Jan. A microphone.
Yeah. Hey, yeah, thanks for the great talk. Really
Sure.
awesome. So you mentioned the Slack page, but it's private, so nobody can actually join without an invite.
Well, there's a URL that's on the marker board for how to join.
Great.
Outside.
Thank you.
Sorry. Oh, turned off just for you.
Sorry. My question was, I expected string view to have actually a large impact on your project. Was it below your expectation?
It was what?
Especially the slicing, that's processing kind of improvements I would have expected. No less copying.
So internally, we were basically, I had already wrapped up our stuff into something that gave me like an index and an offset. But I was able to use string view in many cases that just, it's hard to define, even if it didn't make the code better necessarily in any like tangible way, it did make it feel better. Like there were a couple of cases where I would create like a new offset based on some new range that had been shortened, and now I just get to use remove suffix or remove prefix. And that came up in number parsing, because if I needed to like chop off the negative sign at the front of it or whatever, and yeah. I mean, I liked it, but I just found myself going, I need to tell people you should be clear about what you're using this object for. Yes?
Hey, so I'm not sure if you pay attention to that, but while doing the porting to C++17, did you come up with any specific order to tackle the features when making the changes, so that you don't have a lot of rework or you don't shoot yourself in the foot?
No. I mean, I intentionally tried to keep each commit specific to a specific feature. So I found myself going, well, what feature do I feel like tackling today? I will say that the reason I said that this is either the first part or the third part of a 3-part series, depending on how you look at it, is because this is the one I'm giving first, but it's actually the material that I created last, because I'd already gone through the effort of getting ChaiScript fully const expert and no except correct, and then applied C++17 to it. And then I was already well set up for doing even more with const expert with the functionality that C++17 gave me.
All right, thank you.
Sure. All right. Thanks, everyone.